5A. So apparent weight change. So here's the situation. We're used to normal force and gravity being equal and opposite, but they do not have to be. They can be, they usually are, but they don't have to be. So here's the problem. You're standing in an elevator, it's initially at rest. You know your mass is 61 kilograms. Next, the elevator accelerates up at 1.4 meters per second squared. Then, after a while, it accelerates down at 1.4 meters per second squared. When stationary, you feel normal. When accelerating up, you feel heavier than normal. And when accelerating down, you feel lighter than normal. So, when you're at rest, feel like normal. When you accelerate up, you feel heavy. When you accelerate down, you feel light. So, explain the normal force and the force of gravity are not always the same, and what sensation you feel when that is the case. So, the first thing I want you guys to do, take a minute here, is draw the forces on you in the elevator. So, what are the forces acting on you on the elevator? There's not a lot. We're just going to have up and down forces because we're only worried about vertical motion. So what are the up and down forces going to be acting on you when you're standing in the elevator? So go ahead and draw that, see what you get. What are the forces acting on you there in the elevator? It's always acting on you. It's always trying to get you down, Noah. Go, there we go. Good. Gravity. So we got gravity acting down, and that's in all of these cases. Gravity is acting down on you. Okay? And Hayden, what else is acting on you besides gravity? The normal force. And that's acting up against gravity. So there's a normal force up, normal force up, normal force up. Okay, let's calculate the force of gravity. We'll do this together real quick here. So force of gravity is mg. Mass is 61, we're assuming. G is 9.8. And that is 597.8 newtons. That is the force of gravity. And that is the force of gravity in every single one of these scenarios. 597.8, 597.8, 597.8. So that's the force of gravity for all three of these scenarios. Whether I'm at rest, accelerating up, or accelerating down, the force of gravity is always 597.8. So, in what direction should the net force be in these situations? So, the net force is always in the direction of the acceleration. So, the acceleration is 0 in the first scenario. So, that means the net force is 0 in the first scenario. Okay, the acceleration is up in the second scenario, so the net force should be up. And the acceleration is down in the third scenario, so the net force should be down. Okay. When you talk about weight, the force you feel is the normal force, not the force of gravity. Use the direction of the net force / acceleration in each situation to explain what the normal force should be. Equal to your weight, more than your weight, or less than your weight are fine answers. So what you're going to do is I want you to look at each of these. And I want you to tell me what you should feel. Should you feel or what should the normal force be? Should the normal force be equal to your weight? Should the normal force be more than your weight? Or should the normal force be less than your weight? Look at each of these scenarios. Look at the net force. Look at the force of gravity. Look at the direction of the acceleration, if there is one. See if you can figure out what that's going to be. Again, I want to reiterate, you don't actually feel gravity. So even though gravity is the same, you don't feel the same every time. Okay, we mentioned before that you feel normal when it's at rest. You feel heavier when it accelerates up, and you feel lighter when it accelerates down. So what you do feel is the normal force. You don't feel gravity. So see if you can explain why you feel what you do for those situations, okay? I'll give you a few minutes to think about it. See if you can explain why you feel what you feel. Okay, we said that when you're at rest, we said the net force was 0. So if the net force is 0, we know the force of gravity is 597.8. Should the normal force be larger than that, equal to that, or less than that if we're at rest? Takers, what do we think? What do you say? Equal to. And why do you say that?
Because you're not moving upward or downward, so everything is going to balance out.
Yes. The net force is 0. So because the net force is 0, Fn and Fg are going to be balanced. Because there's no more up force than down force. So these forces are going to be equal. So if gravity is 597.8, then the normal force is going to be 597.8. It'll be exactly equal and opposite. Again, not because of Newton's third law, but because the net force is 0. So they have to equal each other if the net force is 0. Good. All right, the second scenario is the net force is up. So the net force is upwards now. So what should that tell me about my normal force? If the net force is up, should my normal force be more, less, or equal to? Hayden? More. Why? Just sounds good. So he's right. The normal force should be more than gravity. The reason why it should be more is because the net force is up. So when we set up our equation, we have normal force up minus gravity down equals the net force. If the net force is up, we need more up force than down force. Well, I can't change gravity, so gravity can't get smaller. So the only thing that can happen would be for the normal force to get larger. And that is what happens. The normal force is going to be larger than gravity. And since we feel the larger or the normal force, we're going to feel heavier. We're used to feeling 597.8 newtons, but we don't feel 597.8 newtons. We feel something more than that. And so because we feel something more than that, we're going to feel heavier to us. Okay, we're going to feel heavier to the circumstance. We're going to feel like we weigh more. And if you've ever been in an elevator that accelerates up, you know that. Like you feel heavier for a short period of time. It's not for a long period of time. For a short period of time, you're going to feel a little bit heavier. Okay? What about the accelerating down? So the net force on this one is down. Yes. So this one, the normal force would be less than gravity. For the same reason. Normal force minus gravity equals a negative net force because the net force is down. So we need to have more negative force than up force. I can't change gravity. It's always 597.8. So the up force has to be less. So there's going to be less normal force up than gravity force down. And that'll make you feel lighter. If you've ever been in an elevator that accelerates down, you've noticed that before. You feel lighter on the way down. Okay? You can make this more complicated too. When you're on your way up but slowing down, you feel lighter again. If you've ever been in an elevator and you like get towards the top and you jump in the air, you can jump higher than you normally jump. And that's because gravity feels less. It's not actually less, but it feels less. And so you can actually jump a little bit higher. Compared to the ground, you're not actually jumping any higher. It just looks like you are. Okay? So that's an option of that. Also on the way down, slowing down, you'll feel heavier. So as you go down and you slow down to the floor you want to be on, you can't jump as high. And that's because gravity feels heavier than it actually is. It isn't actually any bigger. It just feels like it's a little bit larger because of this idea. So at rest, the normal force equals the force of gravity, so the net force is 0. When you're accelerating up, normal force has to be more in order to make you accelerate up. You have to have more up force than down, so normal is the up force. And on the way down, you have less acceleration up, you're accelerating down, so this needs to be larger. It can't change its value, so this number gets smaller. Okay? Any questions there for me? Sweet.